question 1. You have to read the words carefully. 8 less than 3 times a number is no more than 15. So less than is a reversal. So what that means is what comes after the word less than goes first 3 times a number. So this statement, 8 less than 3 times a number, should be 3x minus 8. Is no more than is less than or equal to 15. So the correct choice for number 1 is choice 3. Taking a look at question 2, the first thing you want to do is solve the inequality. So 2x is less than 8. X is less than 4. So if you thought about this on the number line, not including 4, but you are including everything, it's less 20. So the question wants to know positive integers only. You want to think about your positive integers less than 4. So that would be 3, 2, and 1. So the correct choice would be choice 4. Question 3, you have to solve each piece. So 2x is less than or equal to 12. And x is less than or equal to 6. Side, x is greater than or equal to 2. Now this is an AND statement, so that means both conditions have to be met. So looking at my choices, I can eliminate choices 3 and 1 because I know that they're not including the 6 and the 2, and my answer is 2 includes 6 and 2. Then I have to think to myself, okay, which inequality is being shown that states that x is less than or equal to 6 and greater than or equal to 2. So the correct choice would be choice 2. Question number 4. I want to solve this inequality. So I'm going to subtract 5 from both sides. So 4/3 x is less than 12. To isolate the x, you want to multiply by the reciprocal of 4/3, which is 3/4. So x is less than on the top here, 12 times 3, which is 36, and then across the bottom, 4, and 36 divided by 4 is how you would get this number. So the only value of x that's in the solution set is choice 1. Mine is not in the solution set because this is not or equal to. It has to just be less than 9. Question number 5, you really just need to know the vocabulary. So greater than 54 inches tall means that you're not including the 54, so you could have eliminated choice 1. At least 14 years old means you could be 14 or more. So the correct answer choice would be choice 2.
Okay, so for number 6, there's a couple things we want to look at in this question that's going to help us figure out the answer. So this question is talking about a 9th grade class going to purchase a park permit for an upcoming picnic. So the first thing that I really see here is that we're letting x be the number of guests needing to cover the cost of the permit. And it also tells me here that every 9th grader attending is paying 75 cents, while the guests are paying $1.25. So because the guests are being represented by x, I know that I have to multiply $1.25 times x. And they also tell me that there are 200 9th graders, and 9th graders are paying 75 cents. So I also have to make sure I multiply 75 cents with 200. And together, that would make up the amount of money I'm going to be making off my guests and my 9th graders. Now, at the beginning of the question, it tells me in order to purchase this park permit, they need at least $250. So I need to make sure I have more greater than or equal to the 250. So that would be choice 4 for my answer. Number 7. If 5 times a number is less than or equal to 55, what is the greatest possible integer for the value of that number? So the first thing I need to do is set up the inequality. So 5 times a number, I'm going to let x equal the number, so 5x is less than or equal to, that would be this symbol, 55. Now I want to solve for x, so divide by 5. So x has to be a number less than or equal to 11, and it says what is the greatest possible value for the number? I'm allowed to include 11 because it's less than or equal to it. For number 8, we have a fractional inequality. So the first thing I would do is identify my LCD. So I have the numbers 3 and 5 as my denominators. So remember, when we're talking about LCD, we're thinking about multiples of these numbers. So 3, 6, 9, 12, 15, and 5, 10, 15, 20. So you can see that 15 would be the least number that they both have in common in terms of their multiples. So I'm going to just rewrite my inequality over here. So I have a little room. And I'm going to start by multiplying every single term by that LCD. So multiplying by 15 over 1, multiplying by 15 over 1 to each term. When I do that, I'm going to end up with 15m over 5 is greater than or equal to negative 30 over 3 plus 45 over 5. And if I simplify now and divide up into my numerators, I should end up with 3m is greater than or equal to, sorry, forgot an m over here, 45, so 45m over 5. 3m is greater than or equal to negative 10 plus 45 divided by 5 would give me 9m. And now I want to combine like terms. I don't have any like terms on the same side, so I'm going to need to combine my m. So I'm going to start by subtracting the 9m on both sides of my inequality. And I get negative 6m is greater than or equal to negative 10. And divide by a negative. So remember, when we divide by a negative, we have to switch the sign of our inequality. So that's going to change to be a less than or equal to. And this simplifies to be 5/3. Or positive 10 over 6, which then becomes 5/3. So this answer was choice. And then for number 9, give myself a little room here so I can see the question. For number 9, we're dealing with this equation. D is equal to 1/2 a times t squared. And we're being asked to find what is t in terms of a and d. So we're being asked to solve for t. The first thing I would do is I want to get rid of this 1/2, so I'm going to multiply by the reciprocal, so I'm going to multiply by 2 over 1 on either side, which will then cancel out my fraction to 1. On the right side, I get 2d is equal to a times t squared. Now I want to get t alone, so I'm going to divide by a. I have 2d over a is equal to t squared. And now I want to get rid of the fact that t is being squared, so I'm going to square root it on both sides, and I get the square root of 2d over a is equal to t, and this was choice 2.
Okay, taking a look at question 10, we want to find the solution to the inequality. We have to use the distributive property. Negative 2x plus 10 is less than. Subtract 10 from both sides. Negative 2x is less than negative 6. Remember, when you divide by a negative, you have to switch the inequality sign. So x is greater than 3. So if you thought about your answer on a number line, you're not including 3, you're only including values that are greater than 3. So expressed in integral notation, that should be choice 1. Looking at question 11, it'd be a good idea to set up a type number value. So the two types of coins we're talking about are nickels, dimes. I know the number of nickels is n, and the number of dimes is n minus 6, because you have 6 fewer dimes than nickels. The value of a nickel is 5 cents, and the value of a dime is 10 cents. To get the total, you want to multiply the number times the value. So we get 0.05 n times 0.10 times n minus 6. Since n minus 6 is 2 terms, I'm going to put them in parentheses. So to come up with your equation, you're going to add and set your answer equal to the total amount of money you have, which they told you was $1.65. So once you set up your equation, you're able to say choose choice 2. Taking a look at number 12, we want to isolate x in both inequalities. So negative 12 is greater than or equal to 2x. Divide by 2, if negative 6 is greater than or equal to x. And I always like to read with the x on the left hand side. 9 is less than or equal to 3x. Again, you're going to see the x is on the left, so I'm going to move the variable to the left and the number to the right. But when you do that, you have to remember to change the sign. Now here you're talking about an and inequality. So if there are a number where x is less than or equal to negative 6, and also where x is greater than or equal to 3, the answer is no. There's no solution to this, because there are no numbers that meet both of these requirements. Taking a look at number 13, we want to solve this inequality. So x is greater than or equal to 5, or x is greater than 6. Graph these on a number line, so less than or equal to 5 means including 5 and everything below it. Greater than 6 means I'm not including 6, but I am including everything above 6, greater than 6. Now the question asks you to express your answer in interval notation. So looking from left to right, negative infinity to 5, including 5, so using a bracket to represent that, or, which is represented by u in interval notation, we're not including 6, so I'm using a parenthesis to represent that, which is infinity.
Okay, so for number 14, there were two parts to this question. So the first part wanted us to solve for x algebraically. So I'm going to start by distributing the negative 5. So I get 2x. Negative 5 times 3x is going to be negative 15x. So negative 5 times a negative 4 is going to give me a positive 20. It's greater than 5x plus 42 minus 7x. Now I'm going to look to combine some like terms. So I have like terms on both sides of my inequality. So the next line should look like negative 13x plus 20 is greater than negative 2x plus 42. Now I'm going to try to get my x's on one side, my constants on the other. I'm going to start by adding the 2x to both sides. I get negative 11x plus 20 is greater than 42. We'll subtract the 20. And I get negative 11x is greater than 22. And now I'm dividing by a negative 11. So I'm dividing by a negative, so that's going to become x is less than, and 22 divided by negative 11 is negative 2. So that is my answer for that inequality. And if you wanted to just think about what this looks like on a number line, negative 2 would have an open circle, and x is all values less than it. So it's not including the negative 2, but it's everything less than that value. So the second part of this question said if x is a number in the interval negative 5 to 1 included. So that would mean I'm talking about these numbers, negative 5, negative 4, negative 3, negative 2, negative 1, 0, and 1. All of them included because I have brackets. It wants me to state all the integers that satisfy the given inequality, so the one that we just solved, and explain how we determine these values. So I want to think about these 7 numbers, on my number line and where they would fall. So negative 2 I have on here, negative 3 would be here, negative 4, negative 5. This would be negative 1, 0, and 1. So by looking at it on this number line, you can see that the only numbers from that interval that satisfy the inequality would be negative 5, negative 4, and negative 3. So I need to start out by at least indicating that. So maybe crossing these out and showing that those are the only 3 numbers that satisfy the inequality. And now I want to explain that. So I could just simply say that negative 2, negative 1, 0, and 1 do not satisfy the inequality. Because they're not less than 2. I mean less than negative 2. Okay, and then for number 15, being told that Chelsea has $46 to spend at the fair. She spends $20 on admission and $15 on snacks. So I'm just going to underline some things. This is her total amount she has. And she wants to play a game that costs 65 cents per game. Write an inequality to determine and state the maximum number of times x that she can play the game. So you didn't need to write a let statement, but they are telling you here that x is going to equal the maximum number of games. So whether you indicated that or not, now we know what x is. So it's going to cost me 65 cents per game. said she already spent $20 on admission and $15 on snacks, and she only has $46 to spend. So she can only spend less than or equal to that $46. That's the most she can spend. So now we'll now solve. So I'm going to combine some like terms and subtract the 35 so I can start isolating x. Room here. Then I end up dividing. I need to divide by that 0.65 to get x by itself. When you type this into your calculator, you're going to get a decimal that looks like 16.92307 dot dot dot. Now the reason I put that dot 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 is because that number does not end, and I can't show that it ends because that means that I'm rounding when I'm not supposed to round. But again, I didn't answer the question just yet. It told me to determine the maximum number of times she can play the game. So if x is less than or equal to 16.92, the maximum amount of games that she could play would be 16 games without going over that $46 that she has.
Okay, so taking a look at the last question, you want to first start by distributing the 7/3. So that would give you 7/3 x plus 7/3 times 9/28 reduced give you 3x equals 20. I'm just going to put the 20 over 1, so all my terms have a denominator. So I'm looking for the LCD. So the LCD between 3, 4, and 1. We know 1 is going to include every integer 1. So 3, the multiples would be 3, 6, 9, 12, 15, so on, 4, 4, 8, 12, 16, and so on, and 1 we know is going to be 1, 2, 3, 4, 1. So the lowest multiple they all have in common is 12. So that's my least common denominator. So I'm going to multiply each fraction by 12 over 1. So here you would get 84x divided by 3 plus 36 divided by 4 equals 248 divided by 1. Now if you divided 84 by 3, you should get 28x. 36 by 4, you should get 9 equals 240. When you subtract the 9 to solve for x, I got 28x equals 231. When you divide both sides by 28, you get that x equals 8.25 if you wrote it as a decimal, or if you left it as a fraction in reduced form, it would have been 33 divided by 4.